Now, let's put all these layers together. This chart shows the main layers of a convolutional neural network. As you can see, the whole network generally is doing two tasks. The first part of this network is all about feature learning and extraction, and the second part revolves around classification. So, if we look at each operation as a building block, we can see that a typical convolutional neural network might look like this diagram. As you can imagine, though, a typical CNN architecture for an image classification can be much more complicated. It can be a chain of repeating conv, relu, maxpool operations. For example, here we see more than one convolutional layer, followed by a few fully connected layers. Also, note the effect of each single conv, relu, and maxpool operations pass through the image. It reduces height and width of the individual image, and then it increases the depth of the images. For example, the output of the first convolutional layer is an image of depth 8, and the output of the second layer is an image of depth 32. This is very important because using multiple layers, CNN will be able to break down the complex patterns into a series of simpler patterns. If we pass one of the digits through the network, you can see the outputs. In the first convolutional layer, we apply 8 kernels of size 5 by 5. Then we apply relu and maxpool. In the second convolutional layer, we use 32 kernels. Again, we apply relu and maxpool. We connect the outputs to a fully connected layer. Also, we use a second fully connected layer with a lower number of nodes. And finally, we use softmax in the last layer. And now you can imagine that if we use a CNN trained on human faces, the first layers will represent mostly primitive features, for example, the details of each part of the faces, and the next layers represent more abstract patterns, such as the nose and eyes, with the last layers representing more face-like patterns. Now, let's take a closer look at this architecture and see what happens in the training phase of convolutional neural networks. As mentioned, a CNN is a type of feed-forward neural network consisting of multiple layers of neurons. Each neuron in a layer receives some input, processes it, and optionally follows it with a non-linear output using an activation function. So, what is the network going to learn through the training process? Well, it learns the connection between the layers. These are the learnable weights and biases matrices. In fact, the whole network is about a series of dot products between the weight matrices and the input matrix. This means we must first initialize the weights of the network randomly. Then we will keep feeding the network with a big data set of images. We then check the output of the network, and depending on how far the output is from the expected one, we change or update the weights. We keep repeating this process until it reaches a high accuracy of prediction. Of course, this is a very high-level picture of the whole training process. In any case, I hope you've absorbed the main ideas behind CNNs. For a better understanding of convolutional neural networks, I recommend that you run the labs of this module, which will walk you through different layers of CNN. Thanks for watching.